Good evening, everyone, and welcome to another edition of Beneath the Surface with Marine Mammal Care Center. Today, we're being joined by Dr. Barbara Taylor from NOAA's Southwest Fisheries Office. And we're going to hear about a project that I've been involved with for quite some time, and Barb has been involved with for much longer than that. But it's an issue that's near and dear to me. And hopefully after tonight, it's an issue that you will also find engaging and want to do something about as well. So without further ado, let me introduce Dr. Taylor. Dr. Barbara Taylor has been researching marine mammals for over 30 years. She's a senior scientist at the Southwest Fisheries Science Center in La Jolla, California. For 14 years, she led a group of scientists identifying units to conserve using genetic data and has promoted developing guidelines and standards to facilitate naming new taxa of cetaceans using primarily genetic data. She also specializes in estimating risk of extinction and has worked with some of the most endangered species. She has been a member of several endangered species recovery teams and has served on many status reviews of species petitioning for listing. She serves on and formally chaired the Conservation Committee of the Society for Marine Mammalogy. She serves as the listing authority for Cetacean Specialist Group of the International Union for the Conservation of Nature, or IUCN, and co-chairs the Integrated Conservation Planning for Cetaceans team. But I'm just realizing it's a good thing we didn't just say the acronyms in here, or people would be lost already. In 2006, she participated in a survey that failed to find any baiji, the Chinese river dolphin, portending the first human-caused extinction of a dolphin or whale. As a result, she's actively working with other conservation scientists to prevent the extinction of what now becomes the most critically endangered cetacean, the vaquita. In 2016, she received the Society for Conservation Biology's LaRoe Award as a leader in translating the principles of conservation biology into real-world conservation. It's been just an amazing journey, Barb, to get a chance to meet you and to participate in some of the amazing adventures that we've had as well. And I look forward to your lecture. Lastly, but not leastly, I want to thank Marathon for being able to support our lectures. So without further ado, Barb, take it away.
Thank you so much, Dave. It's a pleasure to be here, and I see amongst the audience that there's a bunch of people who know even more about Vaquita than I do. So I don't know why they want to hear me talk, but you'll have a lot of great people to ask questions to. Let me share my screen now. How does that look, Dave? Good. Okay, well, today I'm going to talk about Vanishing Vaquitas, Lessons from a Humble Porpoise. And I'm going to take quite a tour around, starting with a little bit of marine mammal conservation history to sort of put the Vaquita story in context and talk about the recipes for success that have worked in the past, and then consider what Vaquitas can teach us now about changing that recipe, and take in a few lessons from terrestrial species, and finally talk about opportunities to change that recipe. So when I started out as a marine mammalogist, things were quite different. I graduated from high school in the same year that the Marine Mammal Protection Act was passed. And things were really at a crisis stage in an environmental sense. And one of the chief things that was in people's view was industrial whaling. And you can see on the graph sort of the sequential elimination of the great whales from the world's oceans. There were over 2 million killed in the Antarctic and over 200,000 that were killed in the North Pacific. And this was one of the things that prompted both the Marine Mammal Protection Act and also a year later, the Endangered Species Act. Another issue that pushed the Marine Mammal Protection Act was the tuna dolphin issue, which many of you know about, but some of you may not know the full history of that. And it's really a pretty amazing story. In that same year that the Marine Mammal Protection Act was passed, 368,600 dolphins were killed by the US tuna fleet. I mean, that's just a spectacular number of animals to kill in 1 year. And there was a lot of optimism in 1972 that passing this legislation would make an instant impact to solve this problem of all of these dolphins being killed in tuna nets. But the story actually is much more complicated. And I think, ironically, relative to Vaquita, it was a much more tractable problem to solve. There was in 1972, there were some innovations. The numbers of dolphins you can see started to drop, but then the boats switched from US to other flags, and the dolphin number of deaths started to go up. And there was some undercover work by Sam Labuddy that resulted in some negotiations with the StarKist and resulted in dolphin safe tuna cans, which later was put into legislation in the La Jolla Agreement. And, you know, all of that took over 20 years. And during that period, another 2 million dolphins died in the tuna fishery. And it still was a good thing. I mean, it's likely that millions of dolphin lives were saved, but it is a really good example of how long it really takes to change human behavior, even when you know exactly what the problem is. The other thing that was very influential in a positive way in my career is that's me in 1980. And I was working with the Inuit north of Barrow, Alaska, out in the sea ice, counting bowhead whales. And at the time, it was a big controversy in the International Whaling Commission that the US was anti-whaling, but still had apparently uncontrolled whaling of an endangered species in their own waters. And the result of this issue was that the natives formed the Alaska Eskimo Whaling Commission and very successfully controlled the number of animals being killed. And today, they're almost back to historical numbers. And most of the whales that are swimming past Barrow, Alaska, which I got to see again last spring, were actually born since I was standing out on the ice. So a real conservation success. Well, what made these laws and rules effective? Well, there was governmental will that was fueled by public support. There were empowered implementers. There was enforcement, or at least fear of enforcement. There were at least some users that were motivated to sustainable use. There were data to drive the management, NGOs and courts to check implementation, a well-educated and concerned public, and conservation issues that could be solved through regulatory mechanisms. And we'll see how that is not the case for many conservation issues today. So it takes sort of this sweet spot of having all of these different things come together before you get the happy face of a conservation success. So the next experience I'm going to relate was not a positive experience, and it relates to the Chinese river dolphin, or baiji. I was on the 2006 survey where we took these two ships up and down the Yangtze, covered the full habitat of baiji 4 times, both visually and acoustically. And we did not see a single baiji, and we did not hear a single whistle of a baiji. And we had to conclude that while we weren't looking, this species that had been on planet Earth for over 30 million years had gone extinct. And this was a sort of a soul-shattering experience. And it really motivated Lorenzo Rojas Bracho and many others who have worked on Vaquita to come back and try to not repeat that horror with Vaquita, who then became the next most endangered marine mammal. So you can see the tiny distribution as the little yellow spot of Vaquitas in the middle of your screen there. They were only described in 1958. And we believe that they have been basically restricted to that far northern area, and as a result are what we're calling a naturally rare species. So Lorenzo and I did a paper back in the early 1990s looking at what are the most important threats to this naturally rare species. We looked at pollutants and concluded that there was no threat. In fact, they had the cleanest blubber of any marine mammal at the time. We looked at inbreeding depression and concluded that it was no threat, at least yet at that time. There were many calves and they seemed to be naturally rare. Their genetic pattern fit a case that was not something that had been very abundant and come down very recently. The lack of the Colorado River flow is still cited as a major threat to vaquitas, but we didn't find any evidence, and now we have published many papers, still not finding any evidence. The 60 or more vaquitas that have been examined after they died in gill nets were all fat, healthy animals. As long as we've been seeing them, they've had many calves. And of course, we believe that there are many fewer vaquita out there than the habitat supported in the past. So there's really no reason to think that they might be food limited. And then we looked at bycatch, which is accidental death in gill nets. And it was clear that it was a threat. You can see these pictures. These are early pictures of vaquitas, and they clearly were known to be entangled in gill nets. And the very earliest publications were concerned about this being too much for the species to sustain. But we didn't have the data we needed to say that. There's about 1,000 pangas in the two villages that are adjacent to vaquita habitat, El Golfo de Santa Clara and San Felipe. These are these small boats that take fishing nets out in the nearby waters, and they basically use gill nets for catching almost everything. Caterina da Grossa did a study in 1993 to 1995 in El Golfo, and she estimated that there were about 78 vaquitas that were killed annually, and sort of to her surprise found that they were killed in all types of gill nets, from the small mesh ones that are used to catch shrimp to the large mesh ones that are used to catch totoaba and sharks. So we then needed to put that in the context of 78 out of how many. So we needed an abundance estimate in the full area of vaquitas. Oh, all right, where is my? So this was a film that was taken in 2008 by Chris Johnson. It's still the nicest footage, I think, of vaquitas. And you can see that they are not easy animals to see. This is a close vaquita. And typically they're in groups of two, and they do this slow rolling behavior. They're not a very big animal. They're about my size, about 5'2" and 120 pounds. So they're quite a small animal. They don't splash around. And so they're difficult to see in the best of circumstances. But as if that weren't bad enough, they avoid engine noise. And so they stay out of the way of any motorized vessel, which means from a large ship or even from a small panga, they typically move out of the range that you can see them, certainly with the naked eye and often even with binoculars. So in order for us to go out and estimate how many there are, we had to know more about how to cite these animals and count them. So we went out and did the first survey of the entire distribution of vaquitas in 1997. And there were about 600 vaquitas. We used a method called line transect with the big ship here that could carry these big binoculars that are called big eyes. They're 25 power binoculars. And typically we don't see vaquitas that are closer than about half a mile. So you're looking half a mile out there for a dorsal fin that's about 8 or 9 inches tall. That's a very difficult thing to do. And so you have to have perfectly calm weather to be able to do it. You'll notice that there's also a lot of imprecision, that confidence interval that runs from 200 to 1,000. And that a lot of that comes from, we also had to survey the shallow water areas where the ship couldn't go. And so we had to use vessels and handheld binoculars that where it was much more difficult to see vaquitas. So that was, it's always been a problem telling what's going on in the shallow waters. So after the extinction of Baiji, we decided we needed to do another survey and to develop a method where we could tell what was happening to vaquitas every single year. So we needed to come up with a cheaper method. So we went out in 2008 and did a survey and simultaneously tested a number of acoustic devices. And very conveniently, vaquitas are sort of the hummingbirds of the sea, and they find their food by echolocating. Their echolocation is about 10 times higher than bats. And because they're constantly searching for food and echolocating, it makes them really good subjects to be able to use acoustics to be able to tell at least trends in abundance. And so we paired up the acoustics and the visual, not only to develop this new method, but also to better characterize how many vaquitas were in the shallow water areas. And in the end, we estimated that there were about 250 vaquitas in 2008, which means we lost over 50% of the species in just over 10 years. And that was during a period when most of the fishing was for shrimp and for smaller finfish, so with small mesh nets. And most of those shrimp were being exported to the United States. So, and I have to say all of this, it's just been a tremendous skilled international team of biologists that has made this happen. I'm not going to go through everybody's names. Half of them are on this call. So anyway, it's certainly not all of my work. It's just been a tremendous experience. And so we brought in acousticians with these devices and tested them out to see which one was going to be best suited. And basically the winner was this sort of tube that you can see the arrow pointing at down there that's called a C-pod. It's a passive acoustic detector. And we designed a grid that you see in the map at the bottom. There's a little tiny red line that outlines the Vaquita refuge. That is about 50% of the Vaquita distribution that was being designated as a no fishing zone, and fishermen were paid not to fish there. So the government of Mexico wanted to be able to detect whether that was sufficient and whether vaquitas were recovering. So we designed this 5-year study with 48 C-pods out there for 2 months every summer, which means you get about 3,000 days of data every single year, which is a pretty amazing effort that we thought was going to show us an increase. And instead, what we observed was an accelerating decline in vaquitas after about 2011. that was resulting from the resumption of the Totoaba fishery. So that animal that the gentleman is holding there is a Totoaba. The two villages there are really there established to fish Totoaba. And they were driven along with Vaquita to dangerous levels, and both were put together on the Mexican endangered species list. And but the Vaquitas were not doing well, but Totoaba seemed to be recovering, and we were getting consistent reports from the fishermen that they were seeing a lot of Totoaba out there, adult Totoaba coming up into that far northern Gulf to spawn. And there'd always been sort of an ongoing trade. The original trade was mainly with China for swim bladders that are used for medicinal purposes in China. And there'd been sort of a low trickling trade, but then in about 2011, that increased dramatically when the black market became extremely lucrative, and the price per kilo of Totoaba swim bladder exceeded that of cocaine. So very lucrative and tempting black market operation. The government of Mexico took this very seriously. And in 2015, the president of Mexico came to San Felipe and announced a 4-part program to increase enforcement, ban gill nets within the range of Vaquita, accelerate development of alternative fishing methods, and compensate fishermen not to fish. And the map on the right, I think, is a very useful map. The red zone is the gillnet exclusion zone. And inside of that, you can see the yellow hatched area, which is the historical distribution of vaquitas. The little dots are actual known vaquita detections, either acoustic or visual. And you can see that those little dots are overlaying a sort of light green water. And that greenness comes from the mud that is stirred up by tidal currents running across the muddy bottom that has been laid down historically by the Colorado River. And so it's a very special habitat that vaquitas seem to thrive in. It's incredibly productive, and it's one of the reasons why the two fishing villages were founded and should be able to make a very good living off of this really productive marine ecosystem. We also did another full abundance estimate in 2015, and we found that there were only about 60 vaquitas remaining at that time. And the acoustic data was suggesting a 34% per year decline. But it wasn't all bad news. I mean, we weren't really pessimistic at that point because there seemed to be enforcement actions that were actually taking place. So the Vaquita Refuge that I said was a no fishing zone, you can see it on the radar screen. This is from 2008. I've outlined the Vaquita Refuge in orange. You can see the land is bright, and then in between there's a bunch of colorful little dots. And each one of those dots is a ponga with 1,000 to 2,000 meters of net out. So it wasn't that there was no gill net within the area that vaquitas were using. A lot of it was displaced outside. So we still didn't know whether that was going to help the population or not, but that's what we set up the acoustic monitoring to determine. Then after the 2015 presidential proclamation, when the fishermen were fully compensated, although there were some issues with the compensation plan. But you can see that at least when we were out there during shrimping season, we didn't see any fishing at all. And you can see the radar screen on the lower right the outline of the Vaquita Refuge, and there's just no little ponga dots. The dots you see are actually shrimp trawlers. But when we went back in Totoaba season, which is a little bit later than shrimp season, so it's from December through March and April, the Sea Shepherd and Museo de Ballena, a Mexican NGO, both had ships that were working collaboratively with the Mexican Navy to remove the illegal Totoaba nets. And here you can see a Totoaba net being held up. And they were anchored to the bottom with these giant anchors that you see there. And it was sort of the worst of all worlds for Vaquita. The nets were anchored to the bottom. They didn't have surface markers. So the fishermen left them down there, would just pull them up, take the fish out and drop them back down, as opposed to the normal fishing practice of staying with your net and only letting it soak for 6 hours or so and then taking it out of there. So these nets were what were driving that huge decline that we saw. And it was probably the efforts of those two NGOs that are the reason that there are any vaquitas at all today. They just did a really tremendous job. We used the acoustic monitoring then to continue to project what was going on with the population, and it looked like there were half the number of vaquitas in 2016 that there were in 2015, so a 50% per year decline. So meanwhile, I hadn't mentioned that there was is a Vaquita Recovery team that had been advising the government of Mexico on the status of vaquitas since 1997. And as soon as the declines accelerated because of Totoaba, the recovery team had been discussing the idea that we might need to take some vaquitas into human care, into some sort of protective environment until the Totoaba crisis could be sorted out. And in 2016, the decision was to greatly accelerate what had been a very methodical process and do basically a Hail Mary to try to get as many vaquitas out of harm's way as was possible. And a new group was formed that's called Vaquita CPR, Conservation, Protection, and Recovery. And Dave was part of that effort. And it was an enormous effort. In 2017, in the field, in the fall, we had 90 participants from 9 countries that were to find, catch, house, and care for vaquitas. So we had the acoustic team that modified their methods that were, you put these acoustic recorders out for a long period of time. Now they were doing it on a daily basis. So they would put the recorders out, they would pick them up in the middle of the night. Armando and his team would analyze all the data, and at 4 a.m, I would get a call telling me the locations where they had detected vaquitas. And then the visual team went out to try to locate those vaquitas, and it was a really an amazingly successful system. We were able to get right out and on every good weather day find vaquitas immediately. And then we called in the catch team. The catch team were mainly experienced harbor porpoise catchers from the North Sea, so from Denmark and Greenland. And they brought their specialized nets and methods to be able to catch vaquitas. But then we knew once we caught them, we had to be able to take care of them. And so we had constructed this land facility that had these state-of-the-art clean, sterile pools on the inside that were basically designed in case we had to do emergency evacuations because of hurricanes or something from the sea pen. And then we had a sea pen that was basically a tuna pen that was towed all the way around the Baja Peninsula and all the way up into Vaquita land, and then was modified to be able to, for veterinarians to be able to habituate vaquitas to not eating live fish, for example. And on top of that, we had every porpoise veterinarian in the world in San Felipe to be able to give the best care possible to these animals. We didn't know how they would react to any of this. So the first animal was captured on October 18th. It was about a 6-month-old calf. And the veterinarian said sometimes young animals habituate better than older animals, and they thought they would give it a try. They took this animals to both the land and the sea facility, and it just never acclimated. And meanwhile, our team was out still watching over where the mother was, and they brought the calf out and released it again. The second vaquita that was captured was an adult female, and the initial assessment was very positive. She was not pregnant, not lactating. She had a good heart rate and normal breathing, and they determined that she was a good candidate and moved her into the sea pen. But unfortunately, she, after seeming to be doing okay, she all of a sudden dropped to the bottom, and they tried an emergency release, but she died from capture myopathy. And the veterinarians agreed that taking vaquitas into captivity, this Xc2 option was no longer an option, because there was no opportunity to learn what better to do to not have these animals die of stress when there was only 30 individuals remaining in the species. So that was a crushing blow for all of us. And we had to, try to come up with new ways to keep vaquitas around. We continued with the acoustic monitoring, and there was another 50% decline to 2018. And the recovery team requested that this small area that they had basically retreated to, that was right next to San Felipe, we named it the zero tolerance area, or ZTA, and we requested that that area just be guarded as much as possible to give these animals a chance. And then in 2018, we went out to do a photo ID effort to see whether we could keep track of individuals using that method. And we got this photograph that you see at the bottom. The female on the right with the tattered dorsal fin was the mother of the first calf that we caught. So it was the first evidence that they could have calves every year. She had a new calf in 2018. And that's important because it can potentially double the rate of recovery over what we thought before, which was that they could only calf every 2 years. And there was also some bad news. There was a new administration in the government of Mexico, and they cut off the compensation to fishers. And so the gill nets returned for all of the fisheries and set throughout Vaquita habitat. And in fact, we had a difficult time maneuvering and continue to have that same issue because there are so many gill nets in where the vaquitas are holding out. The Sea Shepherd, it continues to work, but on December 31st, and I'm trying to remember whether it was 2019 or 2020, there was an incident where a fisherman who was basically attacking them, which has been an issue for the last several years. It's just the violence has really escalated. swerved in front of the boat when it was going full speed, and they couldn't avoid it. It collided, and the fisherman was killed. And the government of Mexico, the Navy, asked both the net removal vessels, or all the new net removal vessels, to leave the area. And since then, there really has been very little net removal that's been taking place. We used to have updates, monthly updates, that were on the IUCN, which fortunately you've already had the acronym for, and the CSG part is the Cetacean Specialist Group. And we try to post Vaquita news on there whenever it happens. And we used to post in Totoaba season monthly maps of where the illegal activity was taking place. But that's no longer possible because the agreement, the memorandum of understanding with the Museo de Ballena and the Sea Shepherd requires them to surrender their information to the government of Mexico, and then no one gets it. So we don't have any information about what's going on in this season other than what people are verbally reporting. We did go out in October and early November in 2021. And we were unable to get good photographs that would allow us to do photographic identification and mark recapture estimates. And so we've been using a method called expert elicitation to come up with the number of unique vaquita that are seen in that little tiny area where we have the highest probability of seeing vaquitas, the ZTA. And you can see in 2019, there were about 10 to 12 individuals of sort of the peak probability. And in 2021, it was equal chances of that there were about 7 or 8. But there's lots of uncertainty about that. And in both years, we saw calves, so that's a good thing. And we're just about to submit a paper, so you get the peak preview that actually looks at whether vaquitas are doing better than expected. So we did a model that looked at the numbers that were estimated in 2018, which was the last year that we could do full acoustic monitoring because the sea pods, unfortunately, are getting stolen. And we had the rate of change distribution. And so we were able to project that forward. And those are the black and gray symbols that you see. And then we could compare that to what we observed, which is a minimum number in the zero tolerance area. And you can see that the number of observed is much greater than we would expect if that 50% per year decline had continued. So this is good news. We don't really understand why it is. My personal pet theory is that, these animals that are surviving for a reason. We've lost 99% of the vaquitas. Maybe the 1% that are left have been tangled in nets and are being especially careful. And we certainly observed in 2017 that vaquitas knew where nets were and they knew how to avoid them. And sometimes when they hit the nets, they got out of the nets. And those tattered dorsal fins are also consistent with animals that may have been entangled and gotten out. We also observed, again, really high levels of fishing. Each one of those symbols is for pongas with gill nets out. There's not supposed to be any fishing at all inside the zero tolerance area, which is that little rectangle that's got the points A, B, C, D. And there were, when this was done, 117 pongas inside and 43 outside, all using gill nets illegally. So a very sad scene. And the other thing, if I can get this movie to run here, this is right in downtown San Felipe. And this is basically the traffic jam of uh, uh, hongas going and stand and see like right into the boats, and you can see all the gillnet gear. And what you don't see is you don't see anyone checking paperwork. There's no Navy there. There's no fisheries agency people there. It's basically a free for all in terms of fishing, which was definitely a change for the worse in the past few years. So the lessons from our humble purpose. Well, the greatest threat to marine mammals all over the world is accidental death in gill nets. And we certainly have learned that changing human behavior takes a long time, and it's longer than many coastal and river marine mammals have before extinction. And if we're able to successfully save species by taking them into human care, we have to start much earlier to fill knowledge gaps. You can't wait until you're down to the last few tens of animals. You need to learn what you need to know about how the animals react to handling when there are hundreds of animals. So we know that the recipe for success really has to change from what it has been in the past. So a group of us got together shortly after the tragedy with the Vaquita CPR in Nuremberg, Germany, to discuss some other options, more sort of aggressive conservation that we had to start thinking about for small cetaceans. And here you can see a whole wheel, a clock ticking of cetaceans that are in similar situations to the Vaquita. They just aren't quite as far along. And it was a group of about half veterinarians and half biologists who worked with those species. And we're still working together under the IUCN and have a group that's called Integrated Conservation Planning for Cetaceans that is working to fill a lot of these critical knowledge gaps. Let me spend a minute talking about Xc2 conservation, because a lot of people think it means taking animals into aquariums, and it definitely does not mean that. The IUCN defines it as individuals that are maintained in artificial conditions under different selection pressure than those in natural conditions in natural habitats. And the potential roles are insurance populations, temporary rescues, long-term maintenance, and as a source for population restoration. So I'm going to take a minute and talk about terrestrial species that have been saved using Xc2 conservation that I think we can learn a lot of lessons from. Here, for example, you see a condor. Ironically, that highest peak that you see in the mountains there is San Martir. It's right behind Vaquita habitat, and it's one of the successful places where condors, California condors, who would be extinct without Xc2 conservation, have been released into the wild. There's a really nice book by Jane Goodall called Hope for the Animals, and she documents many cases of animals that have been saved. And this particular list that I've compiled here are animals that went completely extinct in the wild and have been reintroduced back into the wild after a period of being held in various types of Xc2 situations. Condors amongst them, you can see the lowest number of condors was 8. I'm going to talk a bit more about Pierre David's deer because you'll see them, but note that at the lowest point, there were 10 of them, and they were in some private reserve in Great Britain. This is a Chinese species. The only example we have of Xc2 conservation for cetaceans is with Yangtze finless porpoise, which we did see in our 2006 Yangtze survey. And in 1990, they started to move some of the porpoises from the river into these oxbow lakes. And it was basically so they could learn how to take care of animals in the oxbows before they brought in the much more rare baiji. And that's Wang Ding, who's been fundamental in this whole effort. So the Yangtze finless porpoise, sadly, is following the same trajectory as baiji. You can see the 2006, they had greatly declined from the 1991 survey. They are in the river and then some adjacent lakes that you can basically swim in and out of the rivers and the lakes. They were doing a bit better in the lakes than the rivers and still are. And then you can see they declined even further and went on to the critically endangered list to join vaquitas. But meanwhile, they were working very hard developing these oxbow lake insurance populations. So a number of people from the ICPC went to Wuhan, China in 2019, along with COVID, evidently, and learned from our Chinese colleagues what they had been doing and got to go out and witness these oxbow lakes. This is Tianizhu. It's a lake that's about 20 miles long and a couple of miles wide. And the pens that you see here are only for emergency veterinary care. But most of the animals live just like the animals in the rivers do. They swim around, they eat fish, they breed and make babies. I mean, they aren't really doing anything different than they would be in the rivers, except they're completely protected. And the river is having a very strong conservation program because the president of China said that the Yangtze was the mother river of China and that she was sick and that she had to be made well. The fellow with the giant camera there is the Minister of the Environment. He came to see the Yangtze finless porpoise, which he of course did see, but also on the shores, we saw Pierre David's deer, a herd of about 200 of them that have grown up from being released back into the wild. So a very encouraging thing to see them both doing so well there. This is the Yangtze River as I saw it in 2006. And this is the Yangtze River as I saw it in 2019. And those are swans flying over Tianizhu, which means Swan Lake. The boats that you see anchored there are fishing boats. They're there for their last few days. And New Year's of 2020, all fishing except recreational hook and line fishing on the Yangtze was banned. So the lessons from the Yangtze porpoise are that fisheries issues can be solved or reduced with strong governmental will and strong governance, and that semi-natural reserves can provide insurance populations. But again, success took about 20 years. So the recipe needs some very great augmentation over the earlier simple recipe. Users must include all stakeholders that may be affected by conservation actions. Implementers include enforcement, but also parties facilitating economic and social changes. Scientists includes not only animal specialists, but social scientists. And courts include establishing functional system of justice, which is key and not present in the range of many animals that are endangered. And all of these take time. So we need more tools that can give us that critical needed time. So what can be done for vaquitas now? Well, I still believe very strongly that vaquitas could recover if we stopped killing them. Some of the folks on the call tonight actually just got a paper accepted in Science looking at the full genome of vaquita and 20 different vaquitas, some from the 1980s, whose genetic makeup looks like the ones that we got in 2017. So they had very low genetic diversity throughout this whole period. And the simulations that they did indicate that this gives them a strong chance of recovery if you stop killing them, as compared to some simulations where they had larger populations that had more genetic variability. And when they were taken down to 10 individuals, suffered from inbreeding depression and had a lower chance of recovery. So that's, I think, very good news for vaquita. We also have some great examples of recovery of wild populations from low numbers. We have harbor porpoise in San Francisco Bay, Morro Bay, Puget Sound, and Hood Canal that are all coming back, doing gangbusters when they had, in some of those areas, been absent for decades. And of course, we have the great example of northern elephant seals, which went down to no one knows, but roughly 30-ish individuals on Isla Guadalupe off of Mexico. And now there's well over 300,000 of them. And they have reoccupied their former areas along the California coast. We need to really still strongly support net removal and guarding the zero tolerance area. And funding is desperately needed to do that. Mexico still needs pressure to take actions to guard the ZTA and to support alternative gear training and use. And it's something that I really want to emphasize is that the fishermen are trying to make a living. They're just trying to make a living. And the only option that they're being given right now is to be illegal fishermen using gill nets. And the recovery team has been saying for decades that there need to be alternative gears and training so that fishermen can use those gears and not kill vaquitas. And the gears are available, but they've never been implemented properly and socialized with the fishermen. And then there are a number of possible pressure points that are sort of in play right now. And we can talk about them more maybe in the question and answer period. But there are, actually, I can't see the bottom of my slide, but there's the Marine Mammal Protection Act shrimp embargo, which could have some impact, but apparently are leaking into the US and being sold. It seems the mechanisms to control shrimp trade are not very good. There's CITES, the Convention on the International Trade of Endangered Species. They just had a meeting a few days ago, and much to my disappointment, decided that they needed to come take another look and see what Mexico was doing. And then that area is a World Heritage Natural Site. And that also is something that's in review. They put it on the endanger list and are developing some indicators that Mexico must meet before it can come off the endanger list. So I'm going to end with a little bit broader perspective because I think vaquitas are teaching us lessons about cetaceans all over the world, small cetaceans that live in rivers and coastal areas where their entire distribution overlaps with where humans are making a living fishing. And how can Americans help stop extinctions of small cetaceans? Well, I think it really would be important if we could all be good consumers to question whether seafood has been caught with gill nets, and to be supportive, even with our pocketbooks, of sustainable fishing. We have really cheap seafood. Americans are enormous international seafood consumers, and we're not paying the true cost of those seafood products that are going onto our dinner plates. And until we do, there are going to be species that are inadvertently being lost because of our activities. And ultimately, I'll leave you with this: humans need to embrace living sustainably on our planet. And I think we're just seeing so much evidence now with this sixth wave of extinction that we're not doing that, that we really need to think very carefully about how we lead our lives, so that we can protect these innocent species from extinction. Well, with that rosy note, I'll leave it open to questions.
Thank you so much, Barb, for your lecture. I know that
I can't hear you, Dave.
you can't. Can everyone else hear me?
Yeah, I can hear you.
Okay, thank you. Barb, try the thing you did to unmute before, otherwise I'll put it in the chat. Sorry.
Yeah, I still can't hear you. I can try putting on headphones and see if I hear you.
Okay, well, while we're figuring that out, a couple of things I put into the chat. If anybody's interested in this fabulous t-shirt and others like it, we have a company that I've worked with called the 310 Clothing Company, and they'll donate a portion of the proceeds for any purchases on that site to Vaquita CPR, which is a still functioning website that is managed by the National Marine Mammal Foundation. So if you're interested in taking some action after today's lecture and you want to do something to support Vaquita conservation, that is at least one thing you can do, and also help to spread the word. So by advertising, if you're going to wear a t-shirt and it's going to advertise something, why not advertise something that is a conservation that might be core to your own ideas and beliefs, right? Rather than, whatever logo brand you want to put on there. So can you hear us now, Dr. Taylor?
Yes. Yep.
Okay. We had a question earlier on, and I know we have a few experts who might help us to answer this question specifically about the acoustic detections and how we translate acoustic detections to population numbers.
Well, I can try to answer that, and then if Armando's still on, he can jump in. But what we did in the 2000 and in the two surveys is we had the visual area overlap with an acoustic area, so that we knew the numbers of vaquitas in that area, and then we knew basically how many clicks that corresponded to, and then they could use that to estimate in the outer areas. But the real important key part of the acoustic was using it for trends in abundance. So sort of in a nutshell, if you hear 10,000 vaquita clicks in one year and you hear 5,000 vaquita clicks in the next year, you're basically assuming that there's half the number of vaquitas out there making those clicks. So it's a pretty straightforward assumption that they're always needing to find food and that they're always going to be clicking at the same rate. And so you can use that if you have a good abundance estimate, then you can use that to project into the future using acoustics as trends.
So it's an echolocation click, not like a signature whistle. I think people might be familiar with from dolphins.
Right.
Okay, we have another question here, and let's see. Is it possible that some of the vaquita may have migrated out of the area where we've been observing them the most, so that they're in a space where they're not being observed?
I wish. Unfortunately, we don't have any. They're not really migratory. We basically see them in the same place all year, although there's some seasons we know better than other seasons. But we haven't been able to monitor some areas of their historical distribution. So I hope that there are vaquitas that are closer to, let's say, El Golfo de Santa Clara. I mean, we've never been able to monitor that area well. And it is one of the areas where a lot of vaquitas were killed in those early studies that estimated the number of vaquitas killed. But unfortunately, that it's in a shallow water area. And when we put acoustic detectors up there, they were all stolen. So, you know, we can hope they're up there, but we just don't really have any way of knowing that.
Yeah, and regardless, we know their population is low, even if there are a few that may be avoiding detection right now. Probably not enough to give us hope that there's some broader population someplace else. Okay. That was, I think, all of the questions that we have. I want to, unless there are any more questions, I just want to thank you, Dr. Taylor, for joining us tonight, and to let everybody know that we have another member of ICPC that'll be joining us for a lecture on the 17th. Frank Cipriano, who I think is on this Zoom as well, was going to talk to us a little bit about some really cool forensic techniques that are being used in conservation now. So I'm looking forward to that. Hopefully you will be able to join us on that lecture as well on the 17th. So Dr. Taylor, thank you so much for joining us tonight, and we look forward to seeing everybody again on our next Beneath the Surface lecture.
Thank you.
Bye, everybody.